In this video, we're going to briefly discuss the concepts of domain and range. We've been discussing previously the ideas behind relations and functions. When we talk about domain and range, let's go ahead and write these words down. Domain and range, they tie directly into what we mean when we refer to as input and output for functions. We'll say relations in general, but functions. So when we talk about domain and range, we're really just talking about what are all the inputs and what are all the outputs, and it's really kind of a simple definition of it. So I suppose we could just go ahead and list these out here and then look at some examples of it. But we say domain is the set of all inputs that are used by a relation. I'm going to say relation slash function because it could be a special relation, it could be a function. And we say range. I suppose range is the set of all outputs. I'm going to put this in there, or y values, I guess, in general, for a relation or a function. Okay, so I suppose I need to go back up here and modify this guy. So we say inputs, we need to put x values. So when we talk about domain and range, we can look at this, from a mapping or from a table or from a graph. We're going to go ahead and make up a couple of relations here. But we say, what if I had this relation here? We say A. Oops. We say A. And I want to find the domain and range of this relation. So we're going to go ahead and start with a mapping here and represent this in a few different ways. We'll go ahead and populate this with like 1, 2, 3, 4, 5, 6, and 7. And we say, well, let's say 1 maps onto 5 here. We say 2 maps onto 6, and 3 maps onto 7, and we're going to have 4 map also onto 6. We say, looking at this right here, we say this input set over here represents our x values, and our output set here represents our y values. But when we talk about domain and range, looking at the definition, the set of all x values that were used by a relation or function, we would say that the domain of this function, and I know my handwriting is pretty bad there, we'll try to fix that there, but we say the domain is the set of these things, and we say 1, 2, 3, and 4, and the only reason that all 4 of these made it into the domain of this is because they are the x values that got used. And I told you this would be easy. We say the range. What about the range as well? And so when we look at this, we say, well, what are the y values that got used? We say 5, 6, and 7. I know this was kind of a boring example here, but we say those are our range values right there. So just to go through, another example here, we say another relation. What I want to do this time is I actually want to represent it as an input-output chart. We say x's and y's here. So what if I were to re-represent a different relationship this way? A relation, we say 1, 2, 3, 4, and say 5. And we go and take a look at this guy here, and we say, well, 1, let's say 1 goes on to 4, 2 goes on to 2, 3 goes on to 0, 4 goes on to -2, and we'll say 5 goes on to -4. Okay, and so this is what's happening with our relation here, but we say, again, what are the domain and range? So we say domain and range. We can take a look at these. A domain is the set of all x values that got used by our function. We say, well, all of these got used. So we say, well, the domain would be 1, 2, 3, 4, and 5. Okay, and the range here, we say the range is the set of all y values that got used. So we say 4, 2, 0, -2, and -4. Now we're going to see in videos as we proceed here that you don't always include all x values for domain, and likewise all y values for range. There are certain instances where they are excluded, but for the most part right now we just say it's just the set of ones that we use. Okay, and we could have easily have seen this from a graph as well. I mean, if we were to look at a graph of any of these, really, if we were to look at this first or the second relation here, B, really quickly we'll graph these. We say 1, 2, 3, 4. We only went out to 5, and it looks like we got up to a maximum height of +4. We say 5, 5, and a minimum height of -4. So this should be able to accommodate here. And again, when you graph, you should put your arrows on. We say this is the x and this is the y axis. But we say, okay, well, 1 maps onto 4. So the point 1, 4 is on this graph. So here's 1, 4. We say 2, 2 is on our graph. So right 2, up 2. We say 3, 0. So we're going to go right 3, but up and down none. We say 4, -2 is on my relation here. And then 5, -4. We say 5, -4 would be about right here. Okay, and I'm not going to connect the dots because I didn't say that data points existed between these. These are the only ones I have data for, but we say, what is the domain? Now again, domain is the set of all input. We say, well, what input values did my graph go over? It went over 1, 2, 3, 4, and 5. And we say, well, what are my range values? Well, we said it was the set of these y values here, but again, range, we're looking on the y-axis, so we say -4, -2, 0, 2, and 4. Okay, so a brief primer on domain and range. Cheers.